Okay, so what we were doing last week is we learned about nth roots. And with your notes from C15, in other words, let me get back to C15. So actually C17 from last Thursday. The note guide I gave you, you're going to be using this note guide either on Cami or you can put it on a separate sheet of paper, it's up to you. That's what I'm referring to here in this video. Now notice nth roots. Recall that we went over that last week. Right here at this core concepts, it says real nth roots of A. Now the variable A, they're just generalizing the rule for nth roots. A here would be the number inside the radical symbol. Okay, for everything they're going to say right here, all these core concepts, all these rules refers to some number A, just some variable A, that's inside the radical symbol, the root symbol. They call that the radicand. And then of course the number outside right here is called the index, remember from last week. So go ahead and write that in your notes if you're able to. And what this is saying is there's different situations here. If the index, notice n, if it's even, then there's special things that happen. Let's call it case 1, case 2, and case 3 if the index of the radical is even, okay? We're talking about if this number, the root, is even. If the number is odd, if n is odd, okay, the n, if it's odd, let's call this case 1, case 2, and case 3. So let's talk about each one real quick. So you have some space on your notes underneath. Okay, where it says notes, right underneath here. Move that down here. So in this area right here underneath, it says notes on your note guide. Let's go over each case. Case number 1. If n is an even integer, in other words, an even number, okay? Okay, if it's even, and the radicand is less than 0, in other words, if it's a negative number. So let me give you an example. Let's go the fourth root of negative 20, let's say. Notice how the radicand here, the A is a negative number, which means that's right here, A is less than 0 means negative. Anything that's less than 0 is negative. And notice how n, the index, is an even number. If you ever have that case, there's no roots. There's no answer, in other words. And let me put that in my calculator just to prove it. Let me go to my scientific calculator. I actually I posted the scientific calculator on C21. Right here, the Desmos scientific calculator. Okay. Let me type in the fourth root of negative 20. Look at what the calculator spits out. Oops. Notice what the calculator spits out. 20. Notice it's undefined. It doesn't exist. There's no such thing. Okay. Another example would be the square root of, let's say, negative 4. Remember, if I don't put an index, it automatically means the square root. There is no such number multiplied by itself that becomes a negative 4. This would also be no real roots. Notice the index is even, because notice there's a 2 here, even though we don't bother to write it. So the index n is even, and the radicand A is a negative number, so there's no real roots. Notice that. Let's try the second case. What if the radicand is 0, right, and n is even? So let's say n is even and the radicand 0. That would be the second case. Well, let's try the fourth root of 0. This rule is saying, case 2 is saying, then you're going to have 0. The root will be 0. Okay? Now look at the third case now. The third case is, what if the radicand is greater than 0, which means positive, okay? If it's positive, then you're going to have two roots. You're going to have a positive and a negative answer, okay? You're going to have a positive and negative answer. Let me demonstrate. Watch. What would be the square root of 4? Remember, we don't have to put the index. If it's 2, we don't have to write it. It's automatically a 2. I'm just doing it just so you notice that it's a even, n is even. So this is case 3 here. N is even, and notice how the radicand is positive, right? This is a positive number. Look at what ends up happening. You end up having 2 and negative 2. There's two roots. Why, you ask? Well, if you take 2 to the second power, it's 4. And if you take negative 2 to the second power, it's also 4. Notice that.
Dedicated student. You deserve a medal.
Okay, so how about, let's see here. Let me give you another case of the index being even and the radicand being positive for case 3. What if you had the fourth root of 16? That would be 2 and negative 2. Why? Well, 2 to the fourth power is 16, and negative 2 to the fourth power is also 16. Think about it. Negative 2 times negative 2 times negative 2 times negative 2. You multiply all that out to the fourth power, it becomes positive 16. So the upshot, this case 3 right here, case number 3 is saying, look, if the radicand is a positive number, which means it's bigger, it's greater than 0, and the index is even, let me get back there. The index is even, right? Then you're going to have a positive root and a negative root. Okay, now let's look at the examples of odd. Okay, now notice, what if the index is odd and the radicand is negative? So this is the first, I'm putting it in red, the first case when the index is odd. Let's say, what if you had the third root, the cube root of, let's say, negative 8. It's saying you would have one real nth root. So the cube root of negative 8 is going to be, let me go to my calculator. The cube root of negative 8. Notice what it spits out. It spits out a negative 2. Okay? It spits out a negative 2. So you end up having negative 2. Which makes sense because negative 2 to the third power is negative 8, when you think about it. Right? So that's the first case. How about the second case? What if the radicand is 0 and the index is odd? The second case, watch. Let's say, let me get the cube root of 0. That's it. So notice the index is odd. Now the radicand 0. Then this is saying, look, it just becomes 0. It's the second case. The third case, what if you have the radicand positive and the index odd? Let's say the cube root of positive 8. Then that's going to be positive 2 only. You only have one root, not 2. Not 2 like over here. You only have 1. Because a to the third power anything to an odd power is only going to have one root. For instance, 2 to the third power is going to be positive 8. Negative 2 to the third power is not going to be positive 8. It's going to be a negative 8, huh? So that's why you only have one root. If the index is odd and the, the radicand is positive. All right, moving right along. Rational exponents. Okay, we have rational exponents. So when we talk about rational exponents, we're talking about exponents that are just fractions. Rational, it just means fractional exponents. Now here's the main thing that I want you to really pay attention to here. Notice a to the m over n. That's a fraction. Notice. Okay. So rational exponent. All rational means a rational number just means it's a fancy schmancy word for a fraction. So what this is saying is, look, anytime you have a fraction, an exponent that's a fraction, then watch what happens. It's kind of trippy. I kind of taught this last week. Remember you did a flip grid on it. But what this is saying is, look, the numerator of that fraction becomes the exponent outside the parentheses. Okay? Actually, let's skip this part here. Here. Let me back up. All you need to know is that the numerator becomes an exponent outside the parentheses, and the denominator becomes the index of the radical, and the base becomes the radicand. So we can skip this middle part. Just know that when you have a fraction, the numerator becomes the exponent outside, the denominator of the exponent becomes the index of the radical. And same thing with negative. Remember the negative exponent rule? It's going to be the reciprocal, 1 over the same thing. So it becomes 1 over m to the n. Skip this middle part. Okay, this middle part, it's just kind of going step by step. I don't need you to really memorize that part or think about that part. Just know that, look, the numerator becomes the exponent outside, the denominator becomes the index of the radical. Let's try a few problems and I'll shed some more light on it. Watch. Let's go down to those examples. I could find those examples. Hang tight. Okay, here we go. So look at numbers 4 through 11. Scroll down on your note guide. So let's practice this. 64 to the 1/2 power. Let me use now, okay, let me use this rule here. A to the m, the base to a rational exponent. We have a rational exponent, so that means the numerator is going to be the exponent outside, and the denominator is going to be the the index of the radical. So this is really, they want us to do this without using a calculator. Okay, we'll try our hardest. So it's going to be the square root of 64. Actually, yeah, the index is, look at the denominator becomes the index. I'll take all that to the first power. But everything's to the first power, so it's not needed. I don't need to put a power of 1. So this will be my final expression. So I'll take the square root of 64. What number times itself becomes 64? 8 and negative 8, huh? Notice, I have an even index, positive number. That looks to me like the third case over here. Remember? The index is even. Positive number, the radicand is greater than 0, therefore it's positive. Therefore I have 2 nth roots. So you have 8 and negative 8. Right? Because 8 times 8 is 64, and negative 8 times negative is also 64. Let's try the second one. Number 5. So, a radical, I got a negative 27. I got the cube root, right? This becomes that. I have a 1 numerator, so I don't have to put all of that to the first power. That's not needed, because everything's to the first power, right? So that's not needed. It will be needed for example 6, and we're going to get to that right now. But so the cube root of negative 27, what to the third power becomes negative 27? Well, I have a radical that's negative, and an index that's odd. Index is odd, and the radicand is negative. That looks like this. That looks like this case. Case number 1, right? The index is odd, and the radicand is negative, so I know I'm going to have 1/nth root. Let's go back. Here we go. So that's going to be, here we go. It's going to be 1/nth root. What number times itself to the third power will be a negative 27? I'm thinking a negative 3. Yeah, I look at negative 3 times negative 3 times negative 3 will equal to a negative 27. So look, it's only 1 root, it's negative 3. Rocking and rolling. Let's do one more just for this note session for today. Here we go. Now I'm going to use this rule right here. The numerator, now that it's not 1, these are easy. When the numerator is 1, like the examples 4 and 5, that's pretty simple, right? The numerator was 1 of the exponent. Now the numerator is 7, notice. So I'm going to use this rule. The numerator becomes an exponent outside parentheses, and the denominator becomes the index of the radical, okay, like we're used to. So this is going to be now, watch this now. Radical 32, but what kind of radical? It's going to be the 5th root of 32. That becomes a denominator. Okay? The denominator becomes the index. I'm going to take all that now to the 7th power. Okay? So this is the same as this. 32 to the 7th power is really the 5th root of 32 to the 7th power. Let me say that again. Let me say it slowly. 32 to the 7/5 power is really the 5th root of 32 to the 7th power. This is the same as that. That's the main lesson for today. So what is the fifth root of 32? Well, index is odd, radicand is positive. That looks like the third case. Positive radicand, index is odd, n is odd, so it's this third case right here. So I know I'm going to have 1/nth root. Okay, so let's go back down over there. So it's going to be 1 root. What number times itself to the 5th power becomes 32? And I think it's 2, huh? 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times the last 2 is, yeah, it's going to be 32. Nice. So it becomes 2. Okay, watch though. So this is 2. The 5th root of 32 becomes 2, but now I have to take that to the 7th power. So what's 2 to the 7th power? Okay, because they want us to do it without a calculator. So 2 to the 7th power, let me do it right here. 1, 2, 3, 4, 5, 6, 7, yep. 2 times 2 is 4, times 2 is 8, times 2, 16, times 2 is 32, times 2 is 64, times this last 2 is going to be 128. Yeah, there it is. There's our final answer. So without calculator. Now, I could have done it with a calculator, but if it's asking you to do it without calculator, try to do it without the calculator. So first I got the fifth root of 32, that became 2, and then I took that to the 7th power, right here, 128, rocking and rolling.